We're going to work on names and formulas for ionic compounds now, and you want to have handy your naming rules. Specifically, we're focusing on ionic compounds, and then also have your periodic table handy so that you can look for charges on your ions. So we are going to, on this side of the page, work on naming, and it's going to get harder, and then over here, ions and formulas. And I just want to remind you that this is kind of how we think through our names. We will think about going back and forth between ions and formulas like we did a couple pages ago, and then now we're bringing in the names as well. All right, so I'm going to do some of these and then leave some for you to do later on your own. Also remember, if it's ionic, that we will see a metal and a non-metal, and so ionic is always going to have metals. Because that says that at the top of this page, I could go double check this, but every single first element on the page is going to be a metal. And that's true whether we're talking a name or a formula. First element is always going to be a metal, okay? And I know that because it says ionic compounds right there. So looking at naming, okay, we just were talking about some of these rules. Here's K and Cl. So first I need to name the K. Find it on your periodic table. K is potassium. Cl, look over here to see what it changes to. That ending, that suffix becomes "ide." So KCl is potassium chloride. If you have a potassium IV drip, this would be the salt that is dissolved in that potassium solution, most likely. Take a look here. So now the subscript has changed. That has no impact on an ionic name right now, okay? So Mg, if I look that up, that's magnesium. And then F is fluoride. So I have magnesium fluoride, okay? I'm gonna leave a couple and skip down here. Now I see copper, okay? Copper should be a red flag for you. Remember, we had copper and iron were red flag kind of elements. So when I see copper and I see iron, what do I have to add to those names? Those names are going to have to include these Roman numerals to tell me what the charge is on copper, okay? So that means that if I have a formula, before I just jump to the name, I need to figure out the ions first and then go to the name, all right? So how do I do that? So a couple ways. If I have Cu2S, I can take sulfur, find it on the periodic table. Sulfur is a 2 negative charge. And then I can think about my coppers, and I have 2 of those. Remember, in the formula, the charges add up to 0. So each copper must be a positive to cancel out that 2 negative, yeah? Therefore, if copper is a positive, then I could say copper 1 for positive 1, and then I name this sulfide. And all of these elements that are monoatomic anions, I always remember if they're alone, they're going to say, I'd like to be alone. I'd like to be alone. Maybe how you feel after a full day of being cooped up at home with lots of people. I'd like to be alone. And so this is a sulfur that's alone. Copper 1 sulfide. Not telling me anything about the subscript, just telling me what the charges are here, okay? Iron oxide, so same deal, O2 minus, and then I have an iron. So from the O, I can figure out that the iron must be 2 positive. So I name this iron 2 oxide. All right. Now, continuing down to some harder ones, now you see these polyatomic ions have showed up. And if you remember our naming rules, with those polyatomic ions, we are just going to keep the names that I see here. All right. So let's try a couple together. Magnesium is Mg. And then SO4 is sulfate. It will help you tremendously if you memorize these. If you're on campus taking tests and quizzes, you won't have these handy. So it will help you a lot if you can just write these, say them, put all your senses into it, and memorize them. So this would be magnesium sulfate. Let's go down here where these parentheses show up. Don't let the parentheses throw you. They're just saying, hey, this is a package deal. So first Ba, if I look that up, that's barium. And then OH, I come over here, here's OH, hydroxide. All of these end in 8 except for hydroxide. That's the exception. Also, this ammonium and hydronium are strange. We won't see them. But this would be barium hydroxide. Now, at this point, you might start to get confused and be like, well, should I put a Roman numeral on that? What do you think? Don't put a Roman numeral on it unless it's copper and iron. Those only need Roman numerals because they have ambiguity. Kind of like Don Evans Sr. and Don Evans Jr. There was uncertainty about which Don you were talking about, so we add the senior and the junior. There's only one Joanna Hahn. So if I say I am Joanna Hahn Sr., that doesn't make any sense because there's no junior running around, right? So we only use the Roman numerals when there's two to choose from, just like we only use senior and junior when there's two of the same name to choose from. So that was naming these compounds. Now we're going to write a few ions and formulas on the other side, okay? And these you can fill in practice and bring questions also. So now I have a name. I'm going to need to write ions and then a formula, okay? So aluminum. This is where periodic table's coming in handy. Here's aluminum, Al, charge is 3+. So I find it and I figure out the charge. So aluminum, 3+. Nitride, you have to think, is it an ide or is it an 8? Okay, ide means it's all by itself, and when it's all by itself, you're going to come to the periodic table, see the 3 negative, and say, okay, that's N 3-. Okay, 3+, 3-. The formula here is AlN. Okay, let's try the next one down, calcium fluoride. So calcium, if I look that up, is a 2+. Fluorine, if I look that up, is a negative. All right, just to make sure you see where I'm getting this, here's calcium, 2+ because of its group. Fluorine, fluoride, is a negative because of its group. Now let's use our shortcut. Remember, bring the 2 down, and then there's a 1 here, so bring that down, and this would be CaF2, which is a 2+, and then 2 of those F- ions. All right. Let's go down here to iron 3 oxide. Oh, here's an iron and a copper. So red flag, right? Iron and copper are special. So this tells me, I like this Roman numeral, tells me the charge on the iron. Oxide, if I look that up, is 2 negative. So if I cross those charges down, this becomes Fe2O3. This is rust. If you have anything rusty around your house, rusty nail, rusty knife, whatever, this is the formula for rust. So you can try the copper one on your own. All right. Now, getting a little bit more challenging, ions and formulas for these compounds. Let's start with the top one here. Lithium is Li. Look up the charge. It's a positive. Nitrate, when I see those 8s, I'm thinking, oh, go to this table here. So nitrate is NO3 negative. NO subscript 3 and then a negative. Positive, negative, those are going to just smash together nicely. All right. Let's slide down here to calcium hydroxide. Calcium is 2+. Hydroxide, I can see that hydrogen oxide. All right, so OH-. So I have calcium, 1 calcium, and then the hydroxide, or any of these, if I have a polyatomic ion, I have to keep it in its own little bubble and say, okay, hydroxide, and I want 2 of those hydroxides. So this 2 actually goes outside some parentheses. I didn't use the parentheses here because I only had 1 nitrate, but as soon as I go up from 1, then I'm going to need to put those parentheses around my polyatomic ion to say, hey, here's a package deal and I want 2 package deals, or here's a package deal and I want 3 of them. We'll do one more here and then I'll leave the rest for you to practice on your own. Copper 2 phosphate. So copper 2+, right? That's what that 2 tells me. Phosphate over here, PO4 3-. So we're going to bring those down. Copper with a subscript of 3, and then phosphate, remember, is a package deal and has that 2 outside of it. So that is working on some names and formulas. Finish up this page and then we will see more practice. We'll do a couple of these in a moment, but most of these we'll save for class.